All right. So before we do the trig review, there's one more thing I like to go over with you guys about functions and then its inverses. Okay, function and its inverses. All right. So far, we have studied from number 1 through number 14, okay? And of course, we didn't do 7 and 8, but that you're supposed to do that. Those are also very important functions. And right now, we're gonna look at these functions with inverses one at a time, one pair at a time, okay? Starting with the one we have studied the latest, okay? So we know that, okay, number 11, number 13, number 14, I'm gonna leave it for you still, okay? We're gonna just use the function we've studied in class, and we're gonna start with 11 and 12, 11 and 12. So 11 and 12, we have f, right? The function is f of x equals to e to the power x, very important function, okay? And the other function we call it g. But since we know it's inverse of e, therefore we're gonna use a notation of inverse function and put it right here. That equals ln x. Do you guys follow me? Okay. So what I'm gonna do next, and I'm gonna make a table. So we're gonna recap about what we have learned about these two functions. Okay. So this is the function, and your participation is much anticipated and appreciated. Okay. Do you see this little negative sign here? Do you see that?
Yes, but it's a little hard to see. You can barely see it.
I know. So I'm going to make it a little bit larger. How about that? Is that better?
Oh yeah, it makes it a lot better actually. Thank you.
Okay, so I want to make sure you see everything very, very clearly. Okay. We studied yesterday domain and range. Okay, among all things we studied, we particularly take out domain and range to discuss. What is the domain for e to the power x? You on your notebook, you should have a table, okay? You should be able to follow me. I want you to follow me, okay?
Negative infinity to positive infinity.
That's right. Very good. From negative infinity to positive infinity, do we have a vision of it now? You have the picture in your head, right? We have the picture in your head. And, you know, the entire curve is about all of those things we study. We're not going to do all of them together. Today, we're going to focus on domain and range. And we're going to introduce another property about functions that inverse each other, which you have probably learned before, but it's kind of probably didn't register that much. And that what's the range?
E to the power of x is greater than 0.
That's right. So what's the domain for ln x?
Zero to positive infinity.
Does it include 0?
No.
X greater than 0. And what's the range?
Negative infinity to infinity.
Wonderful. Wonderful. Okay. You see, function that has inverse, this guy is 1-to-1, right? We have studied this is 1-to-1 function, 1-to-1 function. So a function, if it has a domain, if this function is 1-to-1, it will have an inverse. And the question is, how many inverses does it have? The answer is one and only. Okay, so each function, each one-to-one function has one inverse function and one inverse function only. So these pairs, they're one and only for each other. It's more like husband and wife. Okay, legally you cannot have two wives, right? We cannot have two husbands either. So, but this is naturally, okay, by defining these functions, defining these rules, their domain and range are naturally decided, and one's domain is the other's range. We see this very clearly. Let's look at another property. Okay? This is called a composition of function. You probably have seen that before, right? F composite G. Have you seen this kind of operation before?
Yeah.
It's called a composite function, right? Composite. Okay. Composite basically allow us to build functions, from basic functions and we can build many functions. In fact, you can build as many as you wish. And each one of those functions will be fitting for the definition. You follow me? So we have these basic functions. It's like the rock, right? And all of these functions together, we can build more function by adding, subtracting, multiplying, dividing, composing, composite. So composite function is defined as such. How does it work? I'm going to draw a picture for you. Okay. What does it mean? What does it mean? We know that function is a rule, right? So we go back to the definition of function again. Function is a rule. It assigns each element in domain exactly one element in the range. So in that regard, so when we have an input, okay, this input will be given to G first. Going from inside out, okay, G. So the first rule is G. And it produces an output. And that output is G of X. And this G of X will serve as an input for the next function. Guess what's the next function? What the next function is?
F.
That's right. Okay. And F has its own rule, but it will apply the rule to G of X because G of X is the input. Okay. So this guy goes in here and eventually we get the composite, which is F of G of X. Do you guys follow me? Now, let's see what happens if this is the G. Let's see what happens if this is G. Okay. Before we see that, you see this X, because this X is from, from somewhere, where should this X be? This X should be from the domain of G. Do you follow me? This X is from the domain of G. Do you follow me? And it comes out, it will be in the range of G. And this range of G is going to be the domain for the F. Well, G is going to be in the domain of F, that relationship, okay? So not only you have to think of the rules applied this way, you also have to think of the domain and range implications. Everything has to fit perfectly. Everything has to fit. Every step of the way, okay? Every step of the way. So this input from domain of G. So even though in mathematics we use X, Y, Z a lot, but until you mention the rule of the function, you will not be able to tell the difference until you see the rule of function. Okay, so this X is from the domain of G. And what's the consequence? This consequence is going to be in the range of what? Of where? Where would it be? This guy will be in the range of F. Do you follow me? Okay, so this is a domain range requirement, consideration. So each step of the way of the composition, you may think this is mathematics, it's very abstract. No, this is used in computer science every day. These ideas is used in computer science every single day. Okay, in the future, you guys are gonna be do coding, right? This is gonna be a routine or object. You're gonna write a code for it. And this is gonna be another code. Okay, so now let's see what happens here. Now this is my F and this is my G. Okay, this is my F, this is my G. So I'm gonna take this guy because I have limited space. I'm gonna put it over here. Okay, so what I'm gonna do is I'm gonna do F composite G. Okay, so understanding this process, we understand this process, don't we? So this process is merely say, okay, I'm gonna take the whole thing together with us, except this time, the G is F inverse. Does everybody follow me? Okay, so this is gonna be F inverse. Okay, and this is gonna be F inverse. And this is gonna be F inverse. Let's see what happens. Okay, because right now we're dealing with concrete functions. Okay, so when we do F of F inverse, what would this be? This will be F of, F of F inverse is ln x. So this is ln x. You follow me? So F inverse, this is what? This is ln x. Do you follow me? And over here, it's gonna be ln x. So F of ln x, I'm sorry, this is remove this. What is F? F is e to the power x. So this is gonna be e to the power of ln x. Okay, so what does this equal to? This equals to e raised to the power of ln x. And what should this be equal to? What does this equal to? What does this equal to? Tell me, everybody. Everybody should know this because by the time you're taking pre-calculus, You should have enough information about logarithm. So tell me, what does it equal to? You need this in calculus. It may not come this route, but you're going to use it very often. What does it equal to?
Asking what f of ln x equals to.
What does this equal to?
Is it equal to x?
That's right. Let's look at this whole process, okay? X is from the domain of g of x. G of x, of course, is ln x. Okay, so I will give you the reason just later, okay? Just 1 second. Okay, right now, let me just scroll up a little bit, okay? Okay, that's fine. What is the domain of ln x? Domain of ln x is what? Positive, right? Ln x, so this x is from the domain of ln x. Okay, the role of the whereabout, the domain of x is determined by the rule that applies to it. Do you follow me? You hear the word I said. Where x should be is determined by the rule that applies to it, or the function that applies to it. Okay, you probably should write it down. This x has ln applied, ln is the rule. So x must be positive, greater than 0. So ln x can be executed, right? That rule can be executed. It comes out as ln x. And what is the range of ln x? From negative infinity to positive infinity. So this number comes out of this rule, can be any real number, and any real number is the domain of e to the power x. So e to the power of any real number, and it equals to x. That's amazing. So input is x, output is also x. Do you guys see that? Is this true?
Yes.
Okay, I hear only one person says it's true. He not only gives the answer. So why is it true? It's true by definition. You see, when mathematics is established, all of these has to be connected, consistent. Okay, you learn this from elsewhere. Okay, so I'm going to show you why. Okay, and then we're going to come back. Okay, why this? We know that ln x, if it equals to a triangle, and what is the definition? E raised to the triangle equals to what?
X.
X, right? From here, from this relationship, you see e to the power of triangle is x. What is a triangle? Triangle is the same as ln x. So we simply replace triangle by its equal. There you go. You guys see that?
Yes.
Can you do it yourself? Did you see what I did? That's the proof. Proof by definition. Proof that by definition. Please do it by your own hands, okay? Watching it is not good enough. Let me tell you. If you are not a mathematical genius, you better do it. Okay, but if you are a mathematical genius, then I don't want you to be in my class because you don't need to. You follow me? So everything I do, you do. Don't do say, oh, I see it, I got it, and I understand it. Guess what? When I was in college, you believe that I was a pretty serious student, right? I took notes and I studied very hard. Right after class, I would go to the library and I would study. And guess what's the first thing I get to? As soon as I get to my library, I'm going to just start doing homework because I thought I understood everything in class. Okay, I took notes. Remember, I took notes. In those days, there's no cell phone taking pictures and none of those. I took notes. So I wrote down what the teacher says and what he put on the board, what he says. A lot of things I try to catch his words, I wrote it down. I thought I understood. But when I hit the homework, in a lot of situations, I realized I cannot get it. I don't know how to do those homework questions. Okay?
Oh, okay, I can get it.
So over time, I developed a method of study because, majoring in mathematics, I would say it's not the easiest thing to do. And I developed a habit because I realized that I cannot just hit the homework right after class. I need to study what was covered in class. Do you guys hear my point? You have to study and redo what the teacher have done in class. Because just because the teacher have done it, it looks easy, it seems understandable, it doesn't mean you can redo it. I cannot redo it. I can only redo it after much struggle. Because as you go through the steps, you realize, gee, I forgot what the reason is, right? Maybe I didn't really get it. Okay, so that was my experience. That's why I'm telling you, unless you think you're a mathematical genius, if you think you're not, you're with me. You're with me. Then you will have to do what I do all over again, maybe 3 more times. Okay, because I had to do it many times at the time. You get it? So now, did you prove that this is true? By definition, substitute this triangle by its equal, because triangle is the same as ln x, therefore this is true. So let's go back where we were, right? F of, so how do we read it? F of f inverse of x equals to what? Equals to x. So if we make this a little shorter, what have we discovered? That is you follow me? And and then you say, well, for this pair of inverse functions, we have that property. Then you say, how about I switch these two functions? Okay, I switch these two functions. Okay, what do I get? Okay. What if I do f inverse composite f? What do I get? What do I get?
X.
ln e to the power of x.
Okay, so let's look at the process. Okay, let's be patient with ourselves. We have an x. What do we give it to?
Inverse first, so ln x.
We'll give it to f first, right? So f of inverse and f of x. Excuse me. Right? So x is given to f of x first. And the rule of f is applied first, which is e to the power x, right? And then it comes out as an input, as an output. This output will be given to what? F inverse, okay, F inverse. So F inverse, forgive me, the software has, sometimes it just have that, you know, that's that kind of thing. I know how to remove it, but it just can be annoying, okay? There you go. So the output will be that. So the inverse rule applies, okay? As we apply this to this concrete function, this x is given to f of x first. We know our f of x is e to the power x, right? Right? E to the power x has its domain and range. So x can be any real number, right? X is from the domain of e to the power x. So x can be any real number. Okay, x can be any real number. And it comes out e to the power x is what? It's positive. And then we apply the ln to e to the power x. And what is coming out of it? What's coming out of it is ln e to the power x. And what does that equal to? Okay, any real number, positive number. Okay, we're going to talk about that comparison just a little bit later. Okay, x is the input. It's from the domain of e to the power x, which is all real numbers. The output come out is positive number only. And that positive number is in the domain of ln x. Therefore, we can apply the rule of ln x. And the consequence, what will be the consequence?
X.
Your knowledge about logarithm should be sufficient to answer that question. What do you think it should be?
X.
That's right. That's exactly right. Definition. Definition. Does anyone need me to explain this why?
Yeah, can you explain it?
Okay. Okay. ln, the definition of ln. So this time, let me use some other symbol. ln of omega. Omega is from the domain of the ln. If and only if. If and only if e raised to the power of triangle is equals to omega. Okay, so now this omega is e to the power x. Okay, so this needs to be e to the power x. And what should the triangle be? The triangle has to be x, right? Therefore, this is x. Did you get it? By definition.
Yeah.
Did everybody get it? Yeah? Yes? All right. So now what do we got? Okay, we got this earlier. And now what do we get here? Right? F inverse We switched the F inverse and F, right? And what do we get here? We got ln e to the power x in this case, okay? Because this is e to the power x. And this equals to x. That is this is also equals to x. I'm sure you have learned this property somewhere before. But I doubt you ever use it very often. Okay, but it's very important now you know. Okay, so I'm gonna single these two out and ask some questions and give you some answers, okay? So when two functions are inverse to each other, not only their domain and range have that special relationship, one's domain, the other's range, vice versa, it also have these two properties. It also has these two properties, okay? So I'm gonna bring these two together. Then the question is that we are saying, well, we are only studying e to the power x and ln x that has such a property. Is this property satisfied by any pair of inverse functions? And the answer is absolutely yes. Absolutely yes. Do you follow me? So it's a universal rule in mathematics. A function and its inverse. Okay. One's domain is the other's range, and vice versa. And you go through these composition, okay? Whichever order you do, this x is from the domain of the inverse function. This x is from the domain of the f function. Even though they're both called x, they are different things. They mean different things. Do you follow me? So in mathematics, when you see x, this x and the other x are not the same. X is just a placeholder. X is just a placeholder. You have to look at the rule that applies to the x to determine what x can be. Do you follow me? Let me see it again. Okay. X and x are different. Okay, so I'm gonna bring this up, okay? I'm gonna put it under here. Okay, this x is from the domain. It's from the domain of f inverse. Okay. This x, however, this x is from the domain of f. These two domains may not be the same. Do you follow me? So even though these two axes, they're both called axes. So now you need to be aware. Okay, that's why you need to write mathematics the way I show you. Is that even though they're both called x, they're not the same thing. The domain of ln x is x must be greater than 0. The domain of e to the power x can be any real number. So as a result of this composition, you get x. As a result of this composition, you also get x. And this property is always true for any pair of inverse functions, which are unique to each other. Do you follow me? Now, let's look at another pair. Okay, so you're going to be studying, maybe we should do 2 and 10 together. How about we do 2 and 10 together, 9 and 10 together? I want you to take the lead. Okay, I want you to take the lead. You guys follow me? All right, so you guys are going to do this pair, okay? Because this will be the opportunity for you to review logarithm. Excuse me. Now, okay, get your paper pencil ratio, paper pencil, okay? What you're gonna do is that we know that 2 to the power x and its inverse is log base 2x. Okay, so I'm gonna set another table for you. And this time you're gonna work on it yourself. Just take the lead, okay? I'll join you later. You know their domain and range, do you? And now I want you to do the composition. Okay, so you put in the domain and range there. And what I want you to compose, oops. Okay, what I want you to compose, for these two functions. Okay, you're gonna composite and that hopefully will wake you up. Okay, so write it down. You're gonna fill these up. Okay, fill this in. Okay, and you do the composition for F inverse. Okay, you know what to do? I can scroll back up so you can see what we did before. Do you want me to do that? Write down what you need to do. Did you write them down? And then you're gonna do these. You're gonna do these. Don't tell me they're the same. You need to do it by yourself. Okay, do it by your own hand to demonstrate they are the same to you. Okay, otherwise it's gonna be, gone very quickly. Okay, after class, you do 3 more times.
Do you want them or the domain
Right?
range?
Self-check. Okay, self-check.
Okay.
Okay. Just give me a sec. I'll be right back. Okay, I'm gonna wash my hands. I'll be right back.
Huh. She went to San Francisco.
Are you done?
Yeah.
Okay, to understand this process, it's very useful, very important. Okay. And these ideas of composition is omnipresent in coding, computer science. Every computer scientist in early days, when computer science was, this area as a science being developed, every one of those researchers was a mathematician. Okay, and a highly accomplished mathematicians. So these mathematical ideas, it permeated throughout the field of computer science. They're still using these mathematical ideas to design language, to design, new tools. Today, of course, the popular, stuff in computer science like AI or, all of these technologies. Okay, their very foundation are from mathematics. Okay, but anyway, without further ado, let's see if you have done the calculation. You've done this. Okay, So now we have F inverse, right? So this is F of F inverse of X. So F of F inverse is log base 2, right? It's log base 2. So log base 2. Right? And what is F? F is 2 to the power of log base 2. What should this be equal to? X. And you can also get it from the definition, isn't it? Yes? Did you get that from a definition? Anybody want me to show you?
Can you show, please?
Okay. Log base 2. Log base 2, sorry, of omega equals to triangle if and only if 2 raised to the power triangle is the same as omega. Yeah. In this latter expression, in the latter expression, you replace triangle by its equal, because triangle is equals to that. Do you see that? Can you do it yourself, please? Did you see what's been done? You need this mathematical skills. Okay, I will not be there when you're taking 90. Okay, your Math 90 professor will not have time to do this for you again in a calculus class.
Professor,
Yes.
how is this different from the functions that we went over before? Like how it started with X and then it would go to ln X. ln X, and then
rules.
the function of ln X.
ln X, the base is E. Log base 2X, the base is 2. The bases are different.
Oh, no, what I meant is how the input, how it started with X and how this time it doesn't start with X.
Well, this is, we started with X here, right? We started.
Okay, so it can be written that way as well. It doesn't have to always to start with just X.
Do you mean here? Are you confused by omega?
I guess so. That's where I'm lost.
This omega and X, they have similar role. They're just a placeholder. Okay, so when X is in this place, and this will be X, and this will be X. Do you see that?
Oh.
You see that?
Okay, I guess what I mean is what I put down is like X leading to log base 2 of X, leading to log base 2 of X, then leading to the function of log 2x, leading to 2 log 2 of x. I started.
I cannot follow you. Could you take a picture and upload it? Do you mind that I share that with the class so I can tell you? You want my feedback, right?
Yeah, I'll write it in the chat.
Would you like to do that? I always appreciate these kind of interactions with the class, okay? You write down something you want to show me.
Okay, I'm writing it in the chat.
Yeah, thank you, very good. So let's see, you put it on the chat? If you wrote down on the paper, you can take a picture and send it on Pronto. You can also upload it on the chat, really. but whichever is easier for you. So I'm going to bring this. I'm going to open up my prompt.
I think this one would be easier.
I really appreciate you sharing this with us. I really do. Okay, the entire class will benefit. And of course, you know, I will critique it, right? I will comment on which is, you know, which part is right, which one is not, and so on and so forth. And you don't mind that, right?
I don't mind. I want to get it right. I want to understand.
Very good. So you have this symbol is larger than? Does that mean
that's the arrow.
Huh?
I don't really have, that's the arrow function.
Okay, so you mean, so I'm going to copy and paste, so I'm going to make it the proper mathematical notation, and I will ask you if that's what you meant, okay?
Okay.
So you mean this is arrow. This is arrow, right?
This is arrow. Yes. Although, mine's a little different, just, yeah.
So this will be probably log base 2, right?
Yes.
Okay. Log base 2x. Thank you for sharing. So this is 2 times log base 2x?
It's like the one right above it, 2 of log 2x. Like the one that you wrote.
Like 2 to the power, right?
Yes, to the power of log 2x.
Okay. In mathematics, because I know you are limited by the notation you can use this software, but when you write on paper or you must write it down properly. Okay, base need to be in the place of base. So you can imagine when you write these things down, you can imagine there's a center line. There's a center line. And the base need to be under. And the exponent need to be above. You follow me? Okay. So with that understood, I think what she did here, I think you meant to do what similar to what we done earlier. So this is the rule. So you probably would put it in the box, right? And the output is log base 2. And then you put this over here. These are the 2 rules. If that's what you have written down, and I would say you've done a good job. However, here you should have an equal sign.
Oh, yeah.
Is that what you meant?
Yes.
Okay, very good. You've done a very good job, but here you need to have an equal sign. Okay, thank you for sharing that. And now we're doing a more mathematical expression here. So I think you're working with this guy first, wait. Okay, you work with this one, yes. So this expression is the same as this graph. You follow me? Let me just make it clear here. Yes? This process you demonstrated, Jesslyn, when we actually write mathematically, we write it this way.
Yes.
You got it?
So that's the top equation is just the proper way to write it out.
That's right. But this way is the way I demonstrate. It's not the wrong way to do it. It's just it's more like a graph, more like a graphic description with a machine, with a function illustration. But in mathematical context, in mathematical textbook, they write it both ways. But I was trying to still, work on that function concept. So you see that how function is done in this composite way. You follow me? And you need to,
Yes.
and all of you need to know both the mechanism. Okay, you need to understand about the mechanism. All right, so let's look at the next one. So F inverse of f of x.
Thank you.
Of course. Thank you for sharing. Okay. And this will be equals to log base 2 of 2 to the power x. And we know what that is equals to, right? That equals to x. Okay, you can also show a similar chart like we did earlier. Did you do that? Did you do that as well, Jocelyn?
Yeah, I did the same thing, but
Okay.
I understand.
Okay, very good, very good. Very good job, very good job. Thank you for sharing. So this is 2 to the power x. Okay, so let's just complete it. I want you guys to thoroughly understand the mechanism going through here. Okay, so this is 2 to the power x. And this serves as input. And we have another function in this case, which is the log base 2 of 2 to the power x. So in the end, you're going to get that guy, and that's going to be equals to x, right? So this is the process I want you guys to go through. Is that clear, everybody? Okay. There are other pairs of such functions in the table of basic 1, such as 7 and 8. Okay. And number 2 is a very important function. Number 7 is a very important function. You're gonna use them a lot in calculus class. But I'm gonna leave this inverse thing to you. Okay. The other thing is I want to remind you of that you must have learned how to find inverse, right? Did you guys learn how to find inverse before? Kind of, sort of.
Yeah, sort of.
Sort of. Okay, this will give you another perspective, of course. And you know the domain and range here. Did you guys answer all of that? Yes? Domain and range here. Did you fill up? Yeah? Same, right? Same. All right, so recall. Okay, I want to give you another perspective to reconnect with what you have learned before. Recall how to find inverse. Okay. If a function is 1-to-1, okay, its inverse is unique. We know that. But how to find it? One of the steps in finding inverse is to swap x and y. For example, I want to give you an example. I'm sure you have done similar examples before. Example. Okay. A typical example would be y is equal to, say, 2x minus 3. Right? I'm just giving you an example. Okay, this function has inverse. Okay, so now we're going to find inverse. Okay, the first step you do is swap x and y. Switch Where's that arrow goes both ways? Come on, guys. Come on, come on, come on. Where is it? This one works, but I wanted to see both sides. Oh, here. Right? So we swap X and Y. What does it mean? X becomes Y, Y becomes X. And of course, the next step, what we do is we solve for Y, right? We solve for Y. Right? That's what you learned before, didn't you? You swap and you solve for Y, yes? When we do this, this is the moment that domain and range swapped. Do you follow me? Do you guys follow me? In your previous experience, you might have learned this before, how to find inverse, right? And one of the steps is swapping X and Y. If you never heard of this, is that the consequence of this is swapping is the reason why one's domain is the other's range and vice versa. Do you follow me? Or at least confirming it. Okay, so this is just another perspective. So can you solve for the Y here? Y should equal to what?
3x over 2.
Equals to half, right? X plus 3, isn't it? Is that right? So if this is the function, and this will be the inverse. But in this case, in this particular case, both functions are linear. Their domain and range they're both the same from negative infinity to positive infinity. So when you swap it, it's still from negative infinity to positive infinity for both. So that's why there were not enough discussion about it at the time. What I'm saying is maybe, okay, when you were learning this before. But not all functions have the same thing. So therefore, we have to consider the swapping of the domain and range. Okay. Well, that's a lot of information. I think we need to take a break and we'll come back. How about that? We will get to the trig function. Okay, trust me, we will get to the trig function. And you will have enough to study for this weekend. And you will have another quiz coming up this week. And I'm still trying to lay the foundation before we catch the trig. Okay, because trigonometry is the hardest part, isn't it? Logarithm is hard for many of you, I believe. Okay, this is speaking from my past experience teaching pre-cal. Trigonometry is harder, okay? So after I covered all of these, and then we're going to trigonometry, and we will be able to relate, okay, and have a better sense and see the consistency and see the simplicity. And of course, at the same time, there's a lot of other issues to deal with. Let's take a break for 10 minutes and come back at 9:16. 9:16. All right, let's take a break. Okay, there are domain issues, right? So we did, you guys done these examples, I'm sure somewhere, before in your past mathematical experience. But if we look at this function ln x or e to the power x, right? If you look at the y equals ln x, how do you find the inverse? You still do the same thing, you still swap. However, the swap comes with the domain constraint. For example, in this swap, right? When you work with this, x must be greater than 0. And y is any real number. Okay, so that's the situation you're working in. You're working within. So we need to have the awareness. We need to have awareness about domain and range. So when we swap, what happens? We ended up working with this. So now we have x equals to ln y. Okay? And this swap not only comes with the, not only just work with this, a definition of function, it also, because the swap of x, y, so these conditions will swap places. Okay, so now is y is larger than 0, x is belong to positive infinity. So the swap has these implications. That's what I'm trying to tell you. Do you guys follow me? Okay, and of course now you can we're going to solve for y. Right? How do you solve for y? Definition, which is y equals to e to the power x. Right? So if this is the function, and that's the inverse function. Okay, so all of these things, they are all related, they're connected, they're consistent. Do you follow me? They're connected and consistent. So now I think we're ready for trigonometry. Okay, we're ready for trigonometry. Okay, now you guys have studied, right? You told me you have studied. So what I'm gonna do is I'm gonna move to the very top. Okay, we're gonna move to the very top. Now, trig review. Okay, I'm glad to hear some of you have viewed the the modules, the postings in the modules. Was that helpful? Was it helpful? Okay, so what are the important things in trigonometry? Could someone tell me what's the important things in trigonometry? Carlos says F composite of inverse.
I was just gonna say, just before we move on, is that correct? Is that true? Right, just to make sure.
No.
No?
No. No. All right, that's a very good question, Carlos. Okay, I'm glad you asked that question. Okay. His question is, did everybody see his question? Okay, Corman says unit circle. Okay, so we're gonna get to that. Okay, the question is, a function has the inverse, has a f of x, and its inverse. Okay, Carlos says, is this true? Since this is equals to x, right? And f inverse composite f equals to x. can we say that these two are equal? Can we say that?
Yes.
Let's see how many yes we have.
Yeah.
Oh no, that's not equal. I meant the f of x. So I meant f and then the parentheses and then the f inverse within it. Is that equal? I know that's not equal because the domains would they would be different.
Right, but that's what you wrote there. That's what you wrote down there.
Oh.
Right.
Oh.
Did I interpret it incorrectly?
Yeah, I meant it's because it's kind of hard to write with this. I don't have the.
Write it on paper and upload it by pronto.
Okay.
The answer is no. Okay, this answer is no. Okay. Just because they are both x's, this x is from the domain of f inverse, and this x is from the domain of f. These two domains may not be the same. Okay? Do you follow me? Examples. Do we have examples? Okay, so we're waiting for Carlos to upload his writing. Are you doing that, Carlos? Okay.
Yeah, I just had my phone off.
No problem. I will give you more examples just later. Okay, it's just 1 second. Let's see what he has uploaded here. You guys find it hard today? What do we study today? Maybe kind of new to you, but not new. I think it's going to be kind of mixture. Some look familiar, some does not, some look weird, and so on and so forth. But we get to apply them. Yeah, Aaron, you got it. The answer should be no, not yes. Just because they're x, just because they call the same name doesn't mean they're the same. Okay, because this x is going to be from the domain of f inverse, and this will be from the domain of f. These two quantities may not be the same. You follow me? Okay, you will see more examples in this area. You will see more examples in this area. Today, I'm going to kind of skip it because you're going to see these in trigonometry much more. Okay, we're gonna see this in trigonometry much more. Okay. That's right. X is just a placeholder. X is just a placeholder. Did you get that, Aaron?
Yeah, now I get it. Thank you.
But I promise you, I will give you examples in the future. Okay. Today, I want to get to the trig. Okay. Examples. So I want you guys to hold me accountable for this. Will come soon. Okay. So if I don't give you examples, you should call me out. Hey, you say you're gonna give us examples. Where are the examples? Okay. Could you remember that for me? You're not gonna let me get away with it, right? Jocelyn, are you gonna let me get away with it? The answer
No.
should be no, no. I should not be getting away with it. Everything I say, I need to be responsible for. Okay? I need to be responsible for. All right, so just
Sorry, my phone is really slow. Can I just send it later in the class?
how about, yeah, let's do it later. Okay, so let's get to the trig. Let's get to the trig. Now, trigonometry. Well, trigonometry, what are the most important things in trigonometry? In your perspective? We asked you these questions yesterday, right? And I asked you about sine, about sine. So from your study, okay, I'm gonna bring up the thing we end up on trig review. Now, do you have an answer to these questions now after your study? Yes, no?
The domain and range for
What's the domain for sine? And what's the range for sine? And what's the domain for arc sine? What's the range for sine, arc sine?
For sine x is all real numbers for domain and all real numbers for range.
The range for sine is what?
All real numbers.
All real numbers, same. How about for arc sine?
-1 to 1.
Could someone, okay. -1 to 1. Anything else? So you guys didn't really study. Some of you studied. So what's the range for arc sine?
I think it's like -pi/2 to pi/2.
That's pretty good. Is it what the way I write it down? Well,
I think so.
we need to plan to spend more time here, huh? All right. So let me critique it. Okay. This is wrong. This is wrong. Okay. This is right. That's right. That's right. Okay. Max is a +1. Min is -1. That's correct. Okay. But this kind of study is not good enough. Do you understand? It's not, you don't have the whole picture. You don't have the whole picture. Okay, we need to know what's important and what is, what comes afterwards. Okay. So I'm going to just go straight to the blood. Okay, what is the most important thing in trigonometry? 3 words, A, R, D. Okay, those of you who took my trig class last semester, you heard of this, right, Carlos? What is A? Trigonometry definition is not as simple as the functions we just learned, we just reviewed, okay? It comes with a stage set and there's some descriptions, okay? So when you're gonna be talking about X, you're gonna talking about Y, you're gonna talking about R, but you have to tell the reader what they are, and the definition is very well written It's in a textbook. So what I'm going to do is that I'm going to tell you the value of reading a textbook. Okay. Where's my cell phone? I have a trigonometry textbook in front of it. Okay, so I'm going to take a picture of that definition for you, and you're going to write down the definition word for word by your pen to your paper. Okay, so just 1 second. I'm going to grab my cell phone. I'll be right back. This is a very serious matter. Very serious matter. Okay. Okay, I found my cell phone. I'm also showing you how to study. Okay. Okay, my pronto. Take a picture. I'm sorry, there's some shade. Do you guys see the picture from your cell phone? Do you see that picture on your cell phone? Yes? It's not the best picture. Okay, can you read it? Can you read that picture? Could you guys read that picture? Okay, so that's the definition. But first, I'm going to tell you what is A. Okay, there's a, I was just telling you, there's a whole stage set for trig function to show up. Okay, so trig functions are the stars. Before they come to the stage has to be set properly. Okay, the first one is how angles are measured. Angle measurement. Okay, and of course, it's in a rectangular system. It's in a rectangular system. Okay, you can imagine that's a stage. Okay, y equals 0. I'm just gonna get started on a stage. Okay, so in that definition, you should see these words as you see the definition, don't you? The number one important thing is when we talk about trig function, you need to have these pictures in your head, because the entire definition is essential. Is essential to your success in trigonometry, and in turn your success in Cal. So what about angle measurement? This basically tells us how angles are measured. How are angles measured? The angles are all measured from here. This is called a standard position. Standard position. You follow me? Standard position. All the angles are measured from standard position. Okay, all the angles are measured from standard position. If you go counterclockwise, it's a positive angle. If we go clockwise, it's a negative angle. Everybody knows that, right? Very important, okay? Very important, okay? Angles, okay, let me use an angle measured counterclockwise is positive. Clockwise is negative. Okay. Second, okay, I will have to move this, okay. So you guys know what I'm talking about is the standard position, right? Second one, reference angle. So R stands for reference angle. R stands for reference angle. Can anybody tell me what is reference angle? Okay, Jocelyn says ratio. Very good. Very good. Okay, we'll get to that. What is reference angle? Could someone tell me what's reference angle?
Isn't it the angle from the axis?
Can you give me a complete sentence?
Wouldn't it be the measurement from the x-axis?
Okay, so give me a complete sentence to describe what's reference angle. Could you do that, please? Give me a complete sentence to describe it. You didn't finish that sentence.
Reference angle is the measurement from the x-axis that is positive.
So what have you studied, right? Any reference, any trigonometry textbook would tell you what is reference angle in a very precise, under precise definition. Okay, reference angle is the positive acute angle between the terminal and x-axis. That's the complete sentence I refer to. Okay, so let me check if I missed any word. Okay. This is how you study in calculus class, you guys. I'm showing you how you study. Every definition has to be carefully studied over and over and over again. Okay, so reference angle is given in chapter 3 in your trig textbook. Okay, a reference angle is the positive acute angle between the terminal of an angle and the x-axis. Okay, between the terminal of an angle, right? Of an angle and x-axis. So reference angle is the positive. Okay, all these adjectives has to be in that place. Okay, positive, acute. What does it mean, acute?
Less than 90? 90 degrees.
Less than 90? That definition is incomplete. Between 0 and 90, because now even you say less than 90, it could be a negative angle, right? Less than 90 would no longer be a precise. It has to be between 0 and pi over 2 or 90 degrees. That's acute angle, but it's because it has to be positive between the terminal of an angle and the x-axis. The third one is a definition. Okay, that's what I sent you. That's what I sent you. Okay, so now I want everybody, did you write it down for me, please? Please, you write it down the entire paragraph on your paper, please. Okay, and there's some descriptions there, definition. Okay, if okay, theta is an angle. You see, I could type this ahead of time, but I do this in class with you because I want you to take the time to write it down along with me, so you can follow the lecture. Okay. If theta is in standard position, if theta is in standard position, and the point x comma y is any point on the terminal side of theta other than the origin, then the function, the trig functions are defined as follows. Okay, so do you have a picture now? Did it in this entire definition, did it mention unit circle? Not at all. Did not mention unit circle at all. Okay, it did not mention unit circle at all. So according to this description, okay, I want everybody to take this picture, okay? And we have a terminal, don't we? This terminal could end up anywhere, isn't it? This terminal could end up anywhere. So what right now, I'm going to just, just put a point. Just put this, just draw an arbitrary terminal. Just draw an arbitrary terminal. Okay, just like that. I'm going to so I want you to draw the same picture on your graph. Okay, just draw a picture. Just draw a picture arbitrarily. Your terminal doesn't have to be in the first quadrant or second quadrant, third quadrant, fourth quadrant. It could be anywhere. Okay. And I'm going to change the view to be more this is just to understand the definition. Okay. You might be a little bit impatient with me right now. You say, why couldn't you just tell us what is the domain and what's the range right now, right here, right now, right? Those information is very easy to find in the textbook. In fact, you can Google it, you find it right now. Okay, I wonder why you guys didn't even Google it, right? But I want to give you a something to fall back on so you can figure out all of these things by yourself from a definition. That's something you need to be able to do when you're in Cal. Okay, so suppose I have a terminal. In this paragraph of description, where is x, y? Where is xy? Where is this point? Tell me, where is this point?
It's at the very tip of
It's on the terminal. That's the key word. The point is any point on the terminal side of theta other than the origin. So they want you to choose a point not at origin, but anywhere on the line. So can you arbitrarily choose a point on this terminal? So you fully understand the meaning, okay? The power of this definition. Arbitrary point. Arbitrary point. Arbitrary point. Okay, that's the arbitrary point. Your point can be here. Okay, you can choose a point over here. Okay, you can choose a point over here. You can choose your point here. You have this arbitrariness of choosing these points. And of course, I choose the black dot. I choose the red dot. Okay, I choose a red dot. And it's arbitrarily chosen. So can you mark this point? Can you mark this point, please? X comma Y, right? X comma Y. Then can you tell me what is X, what is Y? Which piece of length is X and which piece of length is Y? What is X, what is Y? This piece is X. That piece is Y. And this piece is Y. So there's some geometry involved here. There's some geometry involved here. And then we go on to define the trig functions. Okay, then we go on to define the trig functions. Now, and what's next? What is the definition? You see those definition, right? What is theta? Where do you mark the theta? Where do you mark the theta?
In between the X and the terminal side.
That's right. Because every angle is measured from where? From the standard position. Right? But is that theta the only theta with the same terminal? So you can mark this one as theta, right? Yes? Could I also say this is theta too? Could I do that? In trigonometry, you know that if you have the terminal, you have infinite number of angles end up at that terminal, right? And all of these angles will have the same what? Sine value, cosine value, and so on and so forth. So now what does this definition tell us? Okay, so I'm gonna clean this up. Okay, so this is theta. Okay, so I'm gonna try to put the theta not be so dependent on Zoom. Okay, so I want you guys at the same time to write down your definition, please. Okay, write down the definition and tell me what you have learned. Okay, theta. Okay, so that's a theta. It's not in the best place I wished for. Is that better? No. Okay, I give up. Okay, this software just sometimes is a little bit tricky to use. Okay, so delete it. Okay. So we know this angle, right? So we know the terminal. We just need to know the terminal. So this point is x comma y. Hold on, why did I move that? Sorry. Ah, that should be in the 2. That's better. Okay, there. So that's the point. Okay. So now you see the series definitions, right? So sine. So what have we learned here? Sine of theta is what? What is sine of theta? The y over what? R, right? Yes. And what do we say about the R? What's the definition about R? Did they tell us what R? They told us what X is, what Y is. Did they tell us what is R? Because we use R here. What is R? Right? That's R. Okay, so what is cosine theta? X over R. Yeah? Tangent theta. So all of these definitions are given. And what does it tell us? Y over X, cotangent theta is what? X over Y. Okay, so we can keep going. Cosecant theta is equals to what? What's the cosecant theta? R over Y, right? And secant theta equals to R over X. This is the definition. But what does this definition tell us? It tells us that all of these functions, we have 6 functions here, and these functions, each one of them is a rule. And what kind of function, what kind of rule is this? Now we go back to our function perspective. Sine theta. What is the input for sine theta? Theta. Input. And what is coming out? It is a ratio. Okay, it is a ratio. Cosine theta, same thing. Okay, so for all of these angles, okay, so if I'm going to let's see, I'm going to use one column here, 3, 5. Okay, sine, cosine theta, and tangent theta, and cotangent theta, cosecant theta, all of these functions, they take angle as input, and it produces what? Ratio as output. That's what it tells us from the definition. Now, let's come back to study sine. What is a domain? What is a range? Right? What is a domain and what is a range? So now we're going to look at this. I'm going to remove all of these, just sine theta in particular. Okay? This ratio, what is this ratio? This ratio for sine is what? Is y over r. From this definition, you should be able to figure out what is a domain and what is a range. Okay, I'm going to remove this part yet. We know this is wrong. This is wrong. What should be the range?
The range should be -1 to 1.
Can you put it on the chat?
Yeah.
Why is that? You see the range? The range is a ratio. What kind of ratio is it? What kind of ratio is it? It's y over r, right? The y over r. What is y? This is y and this is r. And y is what? Y is one leg of a right triangle. And the hypotenuse is equals to x squared plus y squared. So this ratio will be look like what? Y over, what is the value of r? X squared plus y squared. Right? So what can you tell? If you look at the ratio, right? Of course, the ratio could be on all parts, right? All parts. Right? You could have terminal in every different quadrant, right? So you think of all possible values. Think of all possible values of the ratio of y over r. What can this ratio be? Okay, someone put there from -1 to +1. That is correct or not? Is that correct or not? Did you guys see Cortland's posting there? You're right, Jack. Yes, R is always, yes, that's in the definition. Because what happened is that this is y, right? And that is x. This is the right triangle, isn't it? So the hypotenuse is r. Okay, so the question Jack posted there is, r always root x squared power plus y? Of course, it's in the definition. Definition is more like something carved on the stone. Do you understand what's something carved on the stone? Something carved on the stone. Yes? Set. No question asked. A mathematical definition is for eternity. Mathematical definition is for eternity. Okay? Thank you for your answer, Corlando. Your answer is not correct. Your answer is not correct. Okay, we're bringing the end of the class. Okay, I want you guys to continue this study, but I'm going to give you the answer. The range, if you look at all possible ratios between y and r, okay, this ratio, okay, I'm sorry, let's, I'm trying to get this software to work for me, please. Okay. Okay, this ratio, sorry about that. I'm sorry about that, okay? Right here. This ratio, okay? If you look at the picture, right? If you just look at the picture, this is y and this is r. Y will never be larger than r, right? Because it's one leg of right triangle. Therefore, this ratio, okay? So this ratio, y under this, on this stage set, right? We understand this is a stage. This ratio is going to be greater than or equals to -1, less than or equals to +1. Okay, Cortland is almost right, but he has parentheses between -1 and 1. It should be bracket. So the range is a bracket -1 to 1. Okay, and IE, okay, the sine of any angle. Okay, we'll continue this tomorrow. No, tomorrow is Friday, on Monday, okay? So sine is between, the sine value is between -1 and +1. You follow me? And this is the preferred form. This answer is right, but you never get a point for it. This is the one you need to know and be able to use it because you need this in calculus class. Okay, some of you who took my trigonometry, you knew how much I emphasized these, didn't I? Okay, I will continue to emphasize these until the end of this course. Okay, and of course there's another form. There's another form, okay? We have near to the end of the class, but of course the study is not going to be over. So sine of theta is less than equals to 1 in absolute value. So these two forms are the preferred form. I will be testing you guys left and right over and over and over again. Okay. Okay, so today's homework, you're going to try to figure out why. Okay, as you let your terminal runs through the different quadrants, why that ratio is between -1 and 1. Okay, I have some interesting tools to show you. Okay, and I don't take credit for these tools, but I found them. Thank God some people made those tools. Okay, I will send you the link for you to play with. Okay, I will send you the link for you to play with. So now I'm going to show you. Okay, so here I'm going to show you another page. Okay, someone made these amazing tools for trigonometry study. Okay, and I will send you the link. Let me share that page with you right here. Okay, you see these pages, actually they're still working on it. I'm really glad. I'm really glad to see these links, right? Now, so how you are going to use this, I want you to apply your definition I want you to apply your definition, right? So this is the standard position. You see, this is the standard position. Okay, you're gonna follow the definition. And your terminal could be here, you do the ratio. Your terminal could be anywhere, you do the ratio. Use the definition, you come back. Well, first you need to convince yourself that ratio is gonna be between -1 and 1. Would you do that for me? Yes? And after you've done this for sine, you're gonna work on cosine, and you will work on tangent, and work on cotangent, and cosecant and secant, okay? And we will find out how this definition is so powerful. By setting up the rule, we know the domain and range immediately. You don't need to go to another page or 10 other pages or 3 other chapters to get this information. You can figure out all right here. Okay? That's why we spend all this time on the definition. Powerful stuff, very powerful. So I will see you guys, I'll see you guys on Monday, okay? So I will give you homework. I will send you this link for you to play with. And you should expect another quiz. If not available today, it will be available tomorrow, but you're gonna get it until the end of the week, which is on Sunday. And work on it, okay? Trigonometry is the difficult part for a lot of us. Okay, I want you guys to get started working on it, okay? Get any trig textbook to work on it, to review it, okay? And I will see you guys on Monday. And of course, next is my office hours. And if you have any questions, please don't hesitate to come to my office hours. Okay? Have a great weekend. I see there's a message there. Thank you. Thank you, Tiffany. Of course, anytime. Okay. Thank you, Cortland. Thank you for the contribution.